This is USPS 955 practice test mixed number 2. The point of this practice test is not just to pick answers. The point is to train your eyes. Because the USPS 955 exam style rewards people who slow down, read the setup, trace the diagram, and apply the basic rule before guessing. A lot of these questions are not trying to trick you with advanced math. They are testing whether you understand simple mechanical and electrical logic under pressure. Can you follow motion? Can you trace current? Can you count parts correctly? Can you match the right tool to the right job? Can you recognize what should be checked first when equipment is not working correctly? That is what this mixed set is designed to practice. You will see belt drive direction, fuse logic, block counting, tool identification, pulley mechanical advantage, voltage measurement, right side views, and maintenance troubleshooting. For each question, pause the video if you need to. Try to solve it before the answer key appears. And when you miss one, do not just move on. Ask yourself why you missed it. Did you rush? Did you ignore the diagram? Did you count the wrong thing? Did you confuse similar tools? Did you answer based on memory instead of logic? That is how practice improves your score. Think before you guess. Read, trace, check. Question 1 is a belt drive question. Pulley A rotates clockwise. The question asks, which way does pulley B rotate? The important clue is that this is an open belt drive. The belt is not crossed. It goes around both pulleys in the same orientation. That matters because an open belt keeps the driven pulley moving in the same direction as the driving pulley. So if pulley A rotates clockwise, pulley B also rotates clockwise. The correct answer is A, clockwise. The common mistake is treating pulleys like touching gears. With gears, every gear that touches another gear reverses direction. But belts are different. An open belt keeps the same direction. A crossed belt reverses the direction. So before answering a belt question, ask, is the belt open or crossed? If it is open, same direction. If it is crossed, opposite direction. Here, the belt is open. Pulley A turns clockwise. Pulley B turns clockwise. The answer is A. Question 2 is a fuse logic question. The question asks, if the fuse is blown, what happens to the lamp? A fuse is a safety device. When too much current flows, the fuse opens the circuit to protect the system. A blown fuse means the path is broken, and in a basic circuit, current needs a complete path to flow. If the path is open, current cannot travel from the power source, through the load, and back to the source. So the lamp does not light. It stays off. The correct answer is C, stays off. This is one of the most important electrical habits. Follow the path. Do not just look at the battery. Do not just look at the lamp. Ask whether current has a complete loop. A good fuse allows current to pass. A blown fuse opens the path. An open path stops current. No current means the lamp cannot light normally. It does not get brighter. It does not blink. It stays off. The correct answer is C. Question 3 is a block counting question. The question asks, how many cubes are in the stack? These questions test careful visual counting. The mistake is counting only the obvious cubes or assuming hidden cubes that may not be there. Start from the bottom layer. On the bottom row, there are 3 cubes. Then move up to the next layer. The middle layer has 2 cubes. Then the top layer has 1 cube. Now add them together. 3 on the bottom, 2 in the middle, 1 on top. 3 plus 2 plus 1 equals 6. The correct answer is C, 6. The rule is simple. Count by layers. Do not let the 3D view distract you. Do not count the same cube twice. Do not forget stacked cubes. And do not invent hidden cubes unless the structure clearly requires them. For this stack, the visible and stacked structure gives a total of 6 cubes. The answer is C. Question 4 is tool identification. The question asks, which tool is best for loosening a slotted screw? A slotted screw has one straight slot across the head. That means the correct tool is a flat head screwdriver. The correct answer is B, flat head screwdriver. An adjustable wrench is used for nuts, bolts, and fittings with flat sides. Needle nose pliers are used for gripping, bending, pulling, or reaching small parts. A hammer is used for striking, but a slotted screw needs a blade that fits into the straight slot. That is the flat head screwdriver. The key rule is, match the tool to the fastener. Do not choose the tool that simply looks useful. Choose the tool designed for the shape of the job. Phillips screws need Phillips screwdrivers. Slotted screws need flat head screwdrivers. Hex head bolts need wrenches or sockets. Small parts may need pliers. In this question, the fastener is a slotted screw. The answer is B. Question 5 is a pulley mechanical advantage question. The question asks, which setup gives the greatest mechanical advantage? The key rule is not just to count pulleys. The real rule is to count the supporting rope sections that hold the load. The more rope sections supporting the load, the less force is needed to lift it. A fixed pulley mainly changes the direction of your pull. It does not create much mechanical advantage by itself. A movable pulley can reduce the effort because the load is supported by more than one rope section. A block and tackle style setup can create even more mechanical advantage if more rope sections are actually supporting the moving load. Looking at the options, setup C has the strongest support pattern. It uses multiple rope sections supporting the moving pulley and load, which gives it the greatest mechanical advantage compared with the simpler setups. The correct answer is C. The common mistake is choosing the setup that looks most complicated without checking the rope. Do not just look at the number of wheels. Trace the rope, count the rope segments that help hold the load. More supporting rope sections means more mechanical advantage. For this question, setup C gives the greatest mechanical advantage. The answer is C. Question 6 is an electrical measurement question. The question asks, which instrument measures voltage across a component? Voltage is measured with a voltmeter. The correct answer is B, voltmeter. The phrase, across a component, is important. Voltage is a difference in electrical potential between 2 points. So a voltmeter is connected across the component, meaning one lead goes on one side of the component and the other lead goes on the other side. An ammeter measures current. Current is measured in series with the circuit, because the current must flow through the meter. An ohmmeter measures resistance, usually with the circuit de-energized. A thermometer measures temperature, not electrical voltage. So when you see the word voltage, think voltmeter. When you see current, think ammeter. When you see resistance, think ohmmeter. Here, the question asks for voltage across a component. That is a voltmeter. The answer is B. Question 7 is a spatial view question. The question asks, which right side view matches the block shape? This is different from a top view. A right side view means you are standing on the right side of the object and looking straight at it. The key is to ignore depth. You only care about what shape the blocks make from the right side. Look at the height pattern from that direction. From the right, the visible shape forms a 2-block vertical stack. That matches option B. The correct answer is B. The mistake people make is trying to draw the full 3D object again. Do not do that. Flatten it from the right side. Ask, how many cubes wide does it appear from this side? How tall is the tallest visible stack? What outline would I see if the object were pressed flat from that direction? Option A is too small. Option C adds a side block that does not match the right side outline. Option D shows a horizontal row, which is not the right side height pattern. The right side view matches B. Question 8 is maintenance logic. The question says, a conveyor belt keeps slipping. What should you check first? The correct answer is A, belt tension. A slipping belt often points to a drive or tension problem. If the belt is too loose, it may not grip the pulley properly. That can cause slipping, poor movement, inconsistent operation, noise, wear, or loss of power transfer. So the first logical check is the belt tension. The other answer choices are unrelated. Wall paint does not explain a slipping conveyor belt. Ceiling tile does not explain belt slippage. An exit sign does not explain mechanical belt performance. This question is testing whether you can identify the cause instead of being distracted by random facility details. In maintenance logic, always ask, what is directly connected to the problem? If the belt slips, check the belt system. If a fuse blows, check the overload cause. If a motor overheats, check ventilation, load, bearings, or related operating conditions. If a machine vibrates, check alignment, mounting, balance, or worn parts. The answer should connect to the symptom. A slipping conveyor belt points first to belt tension. The answer is A. Here's the answer key for USPS 955 practice test mixed number 2. Question 1. A. The open belt drive keeps pulley B moving in the same direction as pulley A, so pulley B turns clockwise. Question 2. C. A blown fuse opens the circuit, so current stops and the lamp stays off. Question 3. C. The block stack has 3 cubes on the bottom, 2 in the middle, and 1 on top, for a total of 6 cubes. Question 4. B. A flathead screwdriver is the correct tool for loosening a slotted screw. Question 5. C. Setup C gives the greatest mechanical advantage because it has the strongest supporting rope section arrangement. Question 6. B. A voltmeter measures voltage across a component. Question 7. B. The right side view of the block shape matches the 2-block vertical outline. Question 8. A. If a conveyor belt keeps slipping, check belt tension first. Now use the score correctly. If you got 7 or 8 right, you are building strong pattern recognition. If you got 5 or 6 right, you have a good base, but you need more repetition. If you got 4 or fewer right, do not panic. That just means the basics need more review. Practice is supposed to reveal weak spots. The more you practice, the faster you recognize the rules. Open belts keep direction. Blown fuses stop current. Block stacks should be counted by layer. Tools must match fasteners. Pulley advantage comes from supporting rope sections. Voltage is measured with a voltmeter. Views require flattening the object from the correct direction. Maintenance logic starts with the most likely cause. Review your misses. Practice builds speed.